Cohen, the concept of impulse isn't very tricky, but the vocabulary, you have to really pay attention to the words. So first of all, everybody, momentum is what times what? Mass times velocity. Impulse is defined as a change in momentum, which means you're speeding up or slowing down. Or you could be changing your mass. We're not going to look at that version. If you have an impulse, there's a change in momentum, you're speeding up or slowing down. We're going to be using the phrase change in quite a bit, but I'm telling you, first of all, to begin with, and we're going to put this in our notes, the word impulse is interchangeable with the phrase change in momentum. If you're a Star Trek fan, and of course all of you must be, how could you not be? You may have heard watching Star Trek, they'll talk about the Enterprise having impulse engines. What they were doing was they were changing the Enterprise's momentum. Momentum is what times what? Mass times. They were changing the Enterprise's velocity, not its mass. So they were using it in the correct context. Impulse engines should change momentum. How would you change the momentum of the Enterprise? You'd make it speed up or slow down. Make it speed up or slow down. Cole, can you read to me this first sentence starting with the word prove? We're going to do a proof. I will not ask you to reproduce this on a test, but I like to, if I can, show you where stuff comes from. But Scott, there's something important. And Scott, this is, no, wait a minute. I picked on you with Scott's theorem last time. I'll have to pick on somebody else. Who will I pick on? We're going to go with Jonah this time. Jonah, what's change in anything? Can I give you a hint? This is so important. It's the very first thing. Guys, I want you here. It's the very first thing I put on your green sheet. What's change in anything? Can you all see where that is on your green sheet? Change in anything is final minus initial. I'm going to abbreviate, if you don't mind. I'm going to go that. That's important also for next year. Next year, for example, we'll be learning that work is the change in kinetic energy plus the change in potential energy. It's the final kinetic minus the initial kinetic plus the final potential minus the initial potential. We'll be looking at, if you take Physics 12, the change in voltage. It's the final voltage minus the initial voltage. Anytime you see a change in, it's final minus initial. So again, Cole, can you read that sentence starting with the word prove? Stop. We have a symbol for change in. What's the symbol that we use for change in? Zaina, it's on your formula sheet. What did I use? It's the very first thing on your formula sheet. Okay, now, if you're not a physics nerd, you call that a triangle. What does a physics nerd call that shape to sound more scientific? It starts with the letter D. It's a delta. Okay, so I'm going to say delta. And Zaina, what letter did we use for momentum? Good. Cole, we want to prove that that equals mass times velocity change. And I'm going to walk through there first of all by saying, Jonah, what's change in anything? That's going to be your line for a while. So, okay, this is your big break. There's no small parts. There's only small actors, right? Okay. I'm going to write this then as final momentum minus initial momentum, because that's the very definition of change in. Yeah? Everybody, momentum is what times what? Okay, I'm now, Zaina, going to say that I can write delta P as mass V final minus mass V initial. It seems to me if momentum is mass times velocity, then final would be mass V final, and initial would be mass V initial. You okay with that? Now we're going to GCF. There's an M in everything on the right-hand side. I'm going to write this as M bracket V final minus V initial. And again, you'll notice I'm putting the vector symbols in. We've been kind of casual on the last unit. You're going to see we're going to need to start paying attention to direction again. But Jada, don't worry. We're just going to let one way be positive and one way be Okay, we'll just stick with that. But we will have to notice, oh, this question has the word east and the word west in it. I better let one way be positive and one way be negative. This question has forward and backward in it. I better let one way be positive and one be negative. We're not going to go much beyond that. Hey, Jonah, what's final minus initial the same as? So I can take this and I can write it like m bracket change in velocity. Cole, can you read to me that first sentence again? Prove what? Stop. There's change in momentum right there. Keep reading. Equals. Stop. There's an equals. Yep. Keep reading. Mass. Yes? No. Times velocity what? Oh. That we have? So we have just said, first of all, one way to think about impulse, change in momentum, is it's mass times velocity change. I use this version the most. Sorry, that's a lie. Circled the wrong one. I use this version the most. I usually just go mv final minus mv initial. Okay, that's one way to write impulse. But we haven't defined impulse. So impulse is defined as, don't write this down, look up. Change in momentum. If you feel you have to write that down, you can, but here's what I would suggest. Zaina, what's my abbrev for change in? You told me it starts with letter D. And what letter am I using for momentum? You can write in English change in momentum, or you know enough of me to know, Eric, I'm lazy but organized. You can write delta P, and I'll know what you mean. Impulse is the same thing as change in momentum. But now we're going to start to take that a little further and see if we can link other concepts to it. Example 1 says, fill in the steps below to find the impulse equation. Scott, one last time, if F equals ma, get the A by itself. Okay, we called this Scott's theorem last unit. If VF Ella equals VI plus AT, get the A by itself. Well, we would put a little dot above the A. What's going to drop down like a domino? The VF. Keep going. Yes. Yes. Scott, what does F over M equal? Ella, what does VF minus VI over T equal? Well, if they both equal A, they must equal each other. So on the next line, I'm going to say, I guess that means that F over M equals, don't write this next bit down, look up. I could write VF minus VI over T, but Jonah, what's a clever shorter way to write final minus initial? This is your line. And what's a good symbol for change in? Write that down. The problem with that is fractions, the math F word, not the F word you're thinking of. But wait a minute, this is one fraction equals one fraction. I can cross multiply and I can rewrite this. In other words, dividing by t on the right is the same as doing what with the t on the left? Multiplying. And dividing by m on the left is the same as doing what with the m on the right? Multiplying. On the next page, I can write this. F times t equals m delta v. Now, here's where some notation gets a bit fussy. Time is always been a change in it, because anytime you start and stop a stopwatch, it's actually doing a final minus initial for you. And so many textbooks will always put a delta t right there. I'm going to be sloppy when I handwrite it. I'm often going to leave the delta t off. It's time. But it is technically a change in. And we get this. F delta T equals M delta V, but then it also says substitute the result from the beginning of the lesson. Cole, what did we prove that M delta V was the same as? I gotta be fussy. We did not prove that M delta V equals momentum. We proved that M delta V equals change in momentum. Can you find that on your formula sheet? It should be right next to the momentum equation, I hope. It might be in a different order. I can't remember what order I typed them. But Jada, this is your first time seeing, what, 3 equations in one? We only use 2 at a time. But here's really what we're saying. Jada, delta P equals M delta V, delta P equals FT, and FT equals M delta V. Which one do I use? It depends on what they give me. But I can use either of them as I need. So what does this mean? If you want to change an object's momentum, make it speed up or slow down. What's a fancy word for speed up or slow down? Starts with letter A. Accelerate. If you want to cause an object to accelerate, you need an unbalanced what? Here's what it's saying. If you apply an unbalanced force for a certain amount of time, you're going to cause an object to speed up or slow down. And we give this concept the name impulse. Who remembers from last unit, F equals what? I lied. Newton never wrote F equals ma as his second law. He was much more interested in the concepts of impulse and time. Don't write this down. He wrote it as m delta v over t. In other words, he divided by t to get the F by itself on that line there. That's what he wrote. But wait a minute. Delta v over t, that's a change in velocity over time. That is an acceleration. It's F equals ma in disguise. And this is what I'm trying to get through to you, is this 3 parts in one equation. It's kind of a Swiss Army knife of an equation. Mallory, it contains forces and time and impulse and change in velocities, v final and v initial. I can do an awful lot with this with a tiny bit of cleverness. I wrote here, you can see that this equation is sort of 3 equations in one. I'll often write this third one as mv final minus mv initial, because Jonah, what's changing anything? Final minus initial. Okay? You didn't know, did you? You were freezing on your line, weren't you?
Yeah.
Wow. You can expect a call from your agent. You might be losing this part. So you might notice, Aiden, I've been paying way more attention to vector notation. And this is because in momentum problems, because they involve collisions, there are often changes in direction. So we're going to have to, I wrote here, use precise vector analysis. Well, we're going to have to let one way be positive and one way be negative. Let's do a question. I like example 1. I like example 1. Example 1 is the next question. A baseball is pitched horizontally due east at 38 meters per second after it's hit by a bat and moves horizontally due west at 55 meters per second. Sophie, what does A want me to find? Before I even dive into this, do you see the word east? Look closely. Do you see the word east in the question somewhere? Hey, yes. Do you see the word west somewhere? Do you see 2 different directions? You're going to decide for us, Sophie, which one's going to be positive, which one's going to be negative. Pick. It doesn't matter, but pick. Do you want east to be positive or negative? You're going to let east be negative? Okay. So we're going to be lazy, but organized. So here's how we're going to do this. What did you say east is? Negative or positive? I'm going to put a little negative right in front of the east and in front of the 38. The negative in front of the east to remind me, I've just decided that east is negative. Is that okay, Cohen? Oh, what's west then? Are you positive? That's what. Shut up. Okay, I'm going to put a little plus sign there. You know what, Mr. Duke? What if I can't fit a positive in front of the 55? If I couldn't fit it in front easily, I might even just go like that. Whatever works better for you. But take the time, the 1 second, Scott, to do that. That'll get rid of a bunch of your silly mistakes. Pick a direction and stick with it. It's interesting. The morning class, they let east be positive and west be negative. You let west be positive and east be negative. I would have done it your way for a very obscure reason. See if you can spot why. It doesn't matter. It's all relative. All right. Back to part A. What do they want me to find? Put your pencils down. Look up. Here's how my brain would think. It's a series of checklists. I would be looking at the impulse equation, and the first thing that I would do is I would write down our abbrev for impulse. So you can all write that down. But then I would start looking at the various other iterations of that equation, the other ways I can write that. So don't write this next bit down. My brain would say, well, can I use force times time? Sophie, do you see a force in newtons or a time in seconds anywhere in this question? My brain would erase that in my mind. Can I go mv final minus mv initial, m delta v? Do you see a final and an initial velocity in this question? Do you see a mass? Write that down. And do you see where this came from? You write this down, but I'll show you what my brain actually did. My brain went, well, the formula says this, but this is going to be your line. Get ready. Jonah, what's change in anything?
Final minus.
And so instead of writing that, I would write mv final minus mv initial, because now it's a bit more plug and chug. Okay. What's the mass, Sophie? Good. What's V final? Positive or negative? Okay. Minus. What's the mass? 0.144. What's V initial? What do you get? Time to go to your calculators. Oh, wait a minute. It's not 38. What? So we just made a sloppy mistake that's preventable. We got to kind of raise our paying attention game. It's negative 38. In fact, I kind of get a minus minus, which is going to be a plus. I think I'll get a positive answer here. What's the magnitude of the impulse? Sophie, let me know when you're done. I'm doing some real quick math in my head. Somewhere in the teens, I think. Sorry? 13.4? That's the magnitude. Units. How did we calculate this? I think we went mass times velocity. What are the units for mass? What are the units for velocity? And it's kilogram meters per second. Direction. Which way did you say was positive? Now, if, Braden, you had decided to let east be positive and west be negative, you would have got negative 13.4 kilogram meters per second, and you would have said negative is west. We all would have ended up in the same place. So it doesn't matter which way you let be positive, which way you let be negative, as long as once you decide, stay consistent through the whole question. Eric, is that okay? Okay. Did the ball undergo a change in momentum and impulse? Yeah. Where do you think this impulse came from? Don't overcomplicate this. I'm looking for a three-letter word that starts with letter B. The bat. So a couple of lessons from now, you're going to learn that momentum is conserved. When the bat hit the baseball, it slowed down. It lost some momentum. It gave that momentum to the baseball. The baseball absorbed the momentum. It sped up. That's what happens in any collision. One object loses momentum, the other object gains the exact same amount of momentum. That's a little bit of a teaser of coming attractions. The bat. The bat. Ella M, what's C want me to find? Force. Put your pencils down, look up. This is why I said to you the impulse equation is actually kind of redundant. Because F equals what? You could go like this, don't write this down. And then Ella, you would say to yourself, I don't know A. And you could say, okay, A equals question mark. Well, they gave me VF 55. They gave me VI negative 38 timed. Oh, Ella, what's that lowercase m in front of the seconds and abbrev for? It's on your green sheet. You don't need to I didn't make you memorize these. I just said you need to recognize them when they show up. What metric prefix is that one? Milliseconds, and it's 10 to the what? Okay. So you could say T is 0.8 times 10 to the negative 3. Is that enough for you to find acceleration? Say yes. And then once you did that, got the A by itself, you could then go F equals M. We're not going to do that. But if you did it that way because you were uncomfortable using the impulse equation, I would give you full marks. What did we find in part A, Ella? Is there a version of impulse that has force in it? So everybody, I would now write this. Delta P also equals F times delta T, but I'm too lazy to write the delta. Oh, how would I get the F by itself? One line. That's where the impulse equation is a lovely shortcut. Not several lines finding A and then going back. Turns out, apparently, F is impulse divided by time. What was the impulse? 13.4. What was the time? 0.8 times 10 to the negative 3. Lovely. Which is what? I think you're going to get something in the 13,000, 14,000, 15,000 range, I think, but don't quote me on that. I'm doing some quick math in my head. That one I didn't do in my head. I did a rough guesstimate. Or am I totally off? Ella, what'd you get? 16,000. Say it again. Someone drop something. 16,740. Units. It's a force. What if they'd asked for the direction of the force? Did we get a positive answer or a negative answer? Sophie, what direction did you let be positive? So if they wanted a direction, well, of course, that makes sense. The baseball was coming in east. Of course, the bat had to apply a force west to send it back in the other direction. But it's nice when the Captain Obvious math works. Eric, what's D want me to find? What did I find in part C? By the way, hopefully you've learned when in doubt, when you're on like a part C or a part D, look at your previous answer because you're probably going to use your previous answer to find the next one. What did I find in part C? Starts with letter F. Oh, Scott. I would probably do it that way. You could find the acceleration by going VF equals VI plus AT. There's enough information to do it that way, and then you could get the A by itself. Let's go one line. So it's going to be your answer button, 16,740 divided by 0.144. Eric, what'd you get? That seems... Oh, wait a minute. No, that doesn't seem high. I've watched even baseballs in slow motion. They change direction and accelerate really fast. So I think I'm okay with that. What was it again? Give me the first three. Give it to me the three sig figs. One. Just give me the first three digits. 116. Is it a 6 or a 7? And then I'll just round up. 100,000? Yeah? meters per second squared. Oh, and we got a positive answer, so if they did ask for a direction, which way did you let be positive? Okay. This is a little weird because this morning, this answer was negative, this answer was negative, this answer was negative. That was okay because we let negative be west, but it was the same magnitude. They all matched. We can start to use momentum to analyze collisions, and a good collision to look at, for example, is football tackling. Football tackling. What is the momentum of a 112 kilogram football player running due north with a speed of 3.6 meters per second? Is this question saying what is the impulse? No. So this is not a change in momentum. What's it asking me to find? What is the... Well, momentum is mass times velocity. No delta here. Zayna, keep going. What's the mass? What's the velocity? What do you get? $403.2, and the units, I guess, would be kilogram meters per second. And if they asked for a direction, north. Okay. Okay. Ooh. What's B asking me to find? Impulse. What's another phrase for impulse? Change in? So the very first thing I would write down just to get the juices flowing is I would say, I guess they want me to find this. And I'm going to walk through exactly the same procedure as before. Don't write this next bit down. This is in my brain. I would say, well, first of all, what's changing anything, Jonah? Final. Okay, if you blank out, it's on your green sheet. I might try this. Jonah, do I know the initial momentum? 403.2. Oh, what's the final momentum if we're bringing him to a stop? Oh, you know what? I'm not even going to use the rest of the impulse equation. I can actually use the definition of change it. Write that down. I can go straight to this. I guess it's going to be 0 minus 403.2, which I can do in my head. It's going to be negative 403.2 kilogram meters per second. Or if I wanted to give this a direction, what direction is negative 403.2 kilogram meters per second based on the reference frame that Zaina made up for us? South. Yeah, of course that makes sense. If someone is running north and I want to bring them to a stop, I got to hit them going south. Yes. So, or 403.2 kilogram meters per second south. Okay. So here, I never even got to the F delta T or the M delta B. I was actually just able to use the concept of change in anything is the final thing minus the initial thing. By the way, what's the final momentum of any car accident ever? 0. Just have that in your back pocket if you're ever doing impulse for a car accident. Oh, Plody, what does he want me to find? Force. Don't write this down. Clody, I could go F equals what? MA. And there is enough information in this question that I could find A. I could. However, what did I find in part B? Starts with the letter I. What did I find in part B? Impulse. That three-pronged impulse equation, is there a version that has an F in it? Look at your formula sheet. That three version, is there one that has an F in it? Okay, so I'm going to write this, impulse equals, can you read me the version that has the F in it, please? M delta V doesn't have an F in it. Read me the version that has an F in it, please. Okay. Stop. Write that down. Because let's check. Do I know the impulse, Clody? Do I know time? Good. Get the F by itself. How will I move the T over? Yep. So it's going to be negative 403.2 divided by 0.8. Which is what? Negative 403.2 divided by 0.8. Claudia, you get negative 504? It's a force, units. What's that negative telling me for a direction? Let's go back to part A. Which way did we let be positive in part A? North. That's what Zaina decided for us. So what's this negative telling me, kiddo? The other north. Yeah, which one? South. So I could, if you left it like that, I'd be fine. Or if you wanted to write it as 504 newtons south. In your answers, I would probably write it the second way when you're looking at the answer key. But as long as you're clear on what you've let be positive and negative, I can figure it out. The only thing that I would take a half mark off for is if you said negative 504 newtons and south, because negative south to me is, I think, north. Zaina's scooching ahead. I like that. Like your enthusiasm. Zaina, although we solved this question using impulse, I'm telling you, we could have solved it using VF equals VI plus AT and F equals what? MA. So why am I bothering with momentum and impulse? Well, you're going to find out it's our best tool for analyzing collisions, but we can also explain certain things with the concept of impulse. Turn the page. I'm not going to do this experiment because I don't want to break eggs and waste food, but we're going to do a little thought puzzle. Suppose we have two eggs and we drop them from the same height. Let's pretend the eggs are identical, same mass. Psst. One egg lands on cement and goes split. The other egg lands in a pail of water and survives. Why? Emilio.
The acceleration is it's over a longer time period.
It's over a longer time period. You got to the heart of the matter. So let's walk through this. I want to do a clear explanation with as little writing as possible. So I'm going to write the word cement and the word H2O, draw a little line. If I'm dropping each egg, what's the initial velocity of each egg? 0. So what's the initial momentum of each egg? Actually, you know what? Let's look at impact. What's the final momentum of each egg if both of them come to a stop? Okay, so I'm going to say they both have the same final momentum. 0. Will they both hit the ground or the water at the same velocity if I drop them from the same height? So I'm going to argue they also both have the same initial velocity right when they impact. So if they both have the same final momentum and they both have the same initial momentum, that also means they have the same if they both have the same final momentum and they both have the same initial momentum, why, it follows that they also have the same... Zaina, you're on a roll. Keep going. What? Whatever you had for breakfast this morning, do that more often. Impulse. They both have the same change in momentum. They have to, because if change in anything is what? Final minus initial. Wow, did I cast a bad actor for this particular role? This is worse than the little kid they cast for Anakin Skywalker back in the day, right? And that was terrible. Okay. He was bad. Like, there's just no way around it, right? He's cute! Yeah. Okay. And you don't even qualify for the cute. Never mind. Okay. I'm gonna argue same impulse. Okay? That's step one. Do you agree with me they both undergo the same change in momentum? Now we're going to look at change in momentum in a different way. Here's what Emilio said. So let's do this again, and let's go cement and concrete, Mr. Duick, H2O. Emilio, what's the version of impulse that has time in it?
Force times time.
So his argument is the water makes the time to stop bigger. I'm going to say big time, small force, same impulse. The concrete, small time, big force, egg breaks. You see it? And now Mr. Duick needs to pause the video for a second. That explanation makes sense for car safety? Okay, let's build on that. Next page. I think it's next page. Come on, there we go. Oh, sorry. Actually, damage from change in momentum, from impulse, it's not caused by how much momentum is absorbed. It's how fast the change in momentum has occurred. All of you have gone from 100 kilometers to 0 kilometers. Where? When you're on the freeway, and then you go onto an off-ramp, and then you slow down a bit more onto the low heat, and then you slow down a bit more onto a city road, and then you slow down a bit more in your subdivision, and you slow down a bit more to get onto your driveway, and you come to a stop. You've gone through an impulse, the same impulse as in a car crash, but you spend so much time doing it, you don't even notice the force. It's not like you have to brace yourself before you hit the off-ramp or anything like that. You carry on your conversation, you hardly notice a thing. Okay? So where has this occurred? When leaving the freeway and driving home. But time is so big, 10 minutes probably, that the force is negligible. As opposed to going from 100 to 0 by hitting a brick wall, that's not a good thing to do. Hey, when you're driving to the pit bridge, just before you get to the pit bridge, there's those big yellow barrels, those big plastic barrels. You see them on the road? What are those for? Increased time. Because they also know some people are too dumb to wear their seatbelts. Especially down south. Freedom! Yeah, whatever. Here's another way to think about the egg question. Why do they use bales of hay to line some racetracks, especially motorcycle racing? Well, we can either hit a bale of hay to bring us to a stop, big time, small force, or we can hit a brick wall to bring us to a stop, small time, big force. Option A is much more survivable. In many sports that involve striking something, tennis, baseball, soccer, golf, players are told to follow through when they make impact. How could following through help the ball leave with a bigger velocity? What does following through affect in our impulse equation? It results in a bigger speed. Why? Yeah. Longer time of contact. In fact, anybody here play tennis? To do a drop shot, you pull back right on impact. You try and make time almost 0 so the ball doesn't pick up much of a change in momentum at all, just enough to almost bring it to a stop and drop it straight down. Or if those of you that play baseball, when you bunt, you're pulling back. You want the ball to go very slowly along the baseline. You want minimal time of contact. And that will affect the change in speed. So I agree there's a result. And by the way, change in velocity, because momentum is a vector. We'll be careful with our vocabulary. Yeah. increase. You know what? Let's write it this way, Braden, instead of writing it in English. Bigger time means bigger impulse. If you've lifted weights as much as you can and you can't increase the force anymore, you can still improve your technique. Yeah, follow through. What has more momentum? A 1,000 kilogram car moving at 100 kilometers per hour? Or a 2,000 kilogram truck moving at 50 kilometers per hour? What? The same? How the heck are you coming up with that? Oh, momentum is what times what? Mass times velocity. The units are wrong, but if I go mass times velocity, even with the wrong units, I get the same number. I'd get the same number with the right units as well. So yeah, they're the same. Does a moving object have momentum? How do I calculate momentum? Everybody, momentum is what times what? So does a moving object have mass? Does a moving object have velocity? So does a moving object have momentum? Okay, smarty peoples, turn the page. Does a moving object have impulse? Is that a head shake, Aiden, or was that a I'm stretching my neck because I'm getting tired? Oh. Does a moving object have impulse? What is impulse? So really this is asking, does a moving object have a changing momentum? How do you change your momentum? Okay, does a moving object have to be slowing down or speeding up? What do we call it when it's not slowing down or speeding up? There's a little phrase we used. Okay. Constant. And I'm going to be fussy, Cole. Instead of speed, I'm going to use the vector symbol for velocity. That means the impulse is 0. The only way you can have an impulse is if your speed is wait a minute. We have a fancy phrase for a changing velocity. It starts with letter A. The only way you can have an impulse is if you're accelerating. And the only way you can be accelerating if there's an unbalanced. This is why impulse relates force and Newton's laws and velocities. It's a nice little Swiss Army knife of an equation. When you jump from your lab table to the ground, why do you bend your knees as you land? Emilio.
Time. Increase time.
And that lowers the impact force because we're stuck with the same impulse. In fact, I'm willing to bet all of you, especially as you've gotten older, when you're 6 years old, when you're 5 years old, your mass is so small that the forces involved are small enough that, Mal, you can land wrong and you'll be okay. You can fall backwards off the playground and land on your back and you'll cry, but you'll get up and 10 minutes later you'll be playing around. As adults with your adult bodies, I assure you, if you fall backwards onto your back with your grown-up body, you're not getting up right away and brushing it off and going to play in 10 minutes. You're going to be sore. Or you may have experienced a time when you jumped off of a fence or jumped off of a sun deck or a playground apparatus and you didn't nail the landing. You were a bit off in your bending the knees and you feel it in your spine. So you learn all this when you're 3 and 4 and 5 years old doing all the rough and tumble play that you do as a kid. Which of the following situations is more likely to knock out a boxer? Leaning back while taking a punch? Or leaning in while taking a punch? Clody. Why? I didn't hear. Which one is less time? Leaning in. In fact, leaning back. Leaning back. Time increases, so force decreases. leaning in, time decreases, so force increases. Because you're stuck with the same impulse. Your face has to bring the fist to a stop. Good yawn? We're done. What's the homework? Here's what I assigned my block H's. I think I assigned every question. I did. You're going to find if you hustle, you can get it all done in class. I put a star next to number 6. Why did I put a star next to number 6? You'll have to do some unit conversion, converting those to meters per second before you do the crunching. But try the homework. I think you can get it done in class. Okay? Let me circle the correct ones here, and then I'll turn off the video lesson, and then I'll pay attention to those of you that have questions or want to leave the room because I've been talking for a while.